All right, let's finish off this assignment. 24. A small dog kennel has 8 individual rectangle holding pens of equal size to be constructed using 144 feet of chain. On one side of the kennel is to be placed against a building, so there's no fencing needed there. Find the dimensions that produce a maximum area. So this is an optimization question. So if I label one of the rectangles X and Y, that will give me the area of one of them. So I'm going to start there. But the perimeter, I need to count how many X's across. 1, 2, 3, 4, 5, 6, 7, 8, 9 X's. And how many Y's? 1, 2, 3, 4, 5, 6, 7, 8. And it says the perimeter is 144. How much fencing you need? I'm going to solve for one of the variables. We have too many variables here, so I need to take one out. So we're going to solve for y. So I'm going to subtract 9x and divide everything by 8. 8 goes into 144 18 times. And then I'm going to take that answer, come back over here, and where there's a y, I'm going to put in 18 minus 9 over 8. All right. So now we have one variable, one equation. Our goal is to take the derivative equal to 0 and solve it for the maximum area. Okay, we're going to distribute. Then I'm going to take the derivative of that. That's 18 over 8 equal to 0. I'm going to add. It might be helpful to reduce it down. Actually, it won't be, because if you do the reciprocal, it's 8 over 18, which makes it really simple to divide out, and that you get your answer. So x in this case is equal to 8. Make sure that creates a maximum for the derivative. So if I put in 1, I get a positive answer. If I put in like 10, I get a negative answer. So it does produce a maximum value. Now the question again says find the dimension. So we found one dimension. So one dimension is 8, feet. To find y, we take the answer and plug it into here. And I get 9. So a dimension of 8 feet by 9 feet produces a maximum area for each pen. Second question is, what's the maximum area for each one? You just multiply them together, right? 8 times 9. And that's 72 feet squared. So that's the part B part. All right, 25. 25, you have a block of ice that's melting. Keeps a similar shape as it keeps going, so they're all in ratio to each other as it melts. And it says if the change in the width of the ice is this, negative 1/3 feet per hour, find the rate of the change in volume of the block of ice when the width is 1 feet. So volume is length times width times height. So volume of that is length times width times height. When I look at it, if it's in ratio to each other as it's melting, the length and the width the height and the width are equal to each other. The height and the width are equal to each other. The width and the length, that's 3 over 2 in terms of ratio. So it's 3 over 2 in terms of ratio. So if I know the width, I can go times 3 over 2 and get the length. And now I have one variable. So length is 3 over 2. We have W, and the height and the width are the same. So now we have one variable. Again, what's your goal is to take the derivative. Now, this one is related rate problem with time, so it's a little bit different. So the derivative of v, well, let's first of all simplify this. With respect to time is dv by dt. The derivative here is 3 times 3 is 9 over 2, subtract 1, and then dw by dt. So with respect to time. And then plug in. Now this is what I'm looking for. You're given the width, the change. So the width is 1, they said. So when the width is 1 and the rate the width is changing is negative 1/3. So if I put this together, I get negative 9 over 6, and that's, what is that? Feet per hour. That's the rate the volume is changing at. The second part is what amount of time it'll take for the block of ice to melt. Well, the width every 3 hours so the width is losing a foot every 3 hours. That's at negative 1/3. So how many feet of ice did we start with for the width is 2. So if we multiply top and bottom times 2, and then how many hours would it take to lose 2 feet of ice for the width? So the answer is it'll melt completely in 6 hours, because once you have no width, you don't have an ice, you don't have a block of ice, and so it takes 6 hours for the whole ice to melt. All right, 26, last one. A limit question. The limit as theta approaches pi over 2 for negative 2 cosine theta, and then e to the theta minus pi over 2 minus 1. All right. So evaluate at pi over 2. Cosine at pi over 2 is 0. Pi over 2 minus pi over 2 is e to the 0, which is 1, and then 1 take away 1 is 0. This is an indeterminate. It's 0 over 0 is the form. So we're going to do L'Hopital's rule. Take the derivative of the top. The derivative of cosine is negative sine, so it becomes a negative times a negative, which is positive 2 sine. The derivative of e is you copy it. There's no hook. So the derivative of theta is 1. This is 0, so there's no hook. The derivative of negative 1 is 0, so there it is, just copied. Plug in pi over 2 again. The value of sine at pi over 2 is positive 1, so 2 times 1. Again, plug in pi over 2, take away pi over 2. That's e to the 0. That's 1, and then divide, and you have your answer, and that's it. All right, assignment's over. Mr. G Math, over and out. Glad you finished your work. Until next time.